Imagine a world shrouded in mystery. A world where the stars were distant, unknowable points of light, where the planets roamed the night sky, their movements a celestial puzzle. This was the world before Isaac Newton. Born in a time of intellectual darkness, Newton would become a beacon of light. His mind, a crucible of curiosity, forever changed our understanding of the universe. His discoveries revolutionary, his impact immeasurable. Newton's life was a testament to the power of human curiosity. He dared to question. He dared to explore. And in doing so, he unlocked some of the universe's most closely guarded secrets. Born in a small village in England, Newton's childhood was far from privileged. His father, a farmer, passed away before his birth. His mother remarried, leaving young Isaac in the care of his grandmother. Despite a difficult upbringing, Newton's brilliance shone through. He excelled in his studies, displaying a keen interest in mathematics and the workings of the world. His thirst for knowledge was insatiable. Recognizing his potential, Newton's uncle encouraged him to pursue higher education. In 1661 he entered Trinity College, Cambridge. It was here, within the hallowed halls of this esteemed institution, that Newton's genius would truly blossom. Before Newton, motion was a mystery. Objects moved, but why? What was the underlying principle that dictated their movement? What forces governed their behavior? How could one predict the path of a falling apple or the orbit of a planet? Newton, through meticulous observation and groundbreaking calculations, provided the answers. His work revolutionized our understanding of the physical world. His 3 laws of motion, published in his masterpiece Principia Mathematica, laid the foundation for classical mechanics. These laws became the cornerstone of physics. The first law, inertia, stated that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. This explained why a car stops when brakes are applied. The second law, perhaps the most famous, introduced the concept of force. It quantified the relationship between an object's mass, its acceleration, and the force applied. Force equals mass times acceleration. This fundamental equation, F equals sine ma, became a pivotal tool in understanding motion. This simple equation elegantly explained how objects change their motion when subjected to external forces. It allowed scientists to predict the behavior of moving objects. The third law, action and reaction, stated that for every action, there is an equal and opposite reaction. This principle is observable in everyday life. This law explained why rockets propel upwards when they expel hot gas downwards. It laid the groundwork for modern rocketry and space exploration. Legend has it that Newton experienced his eureka moment while observing an apple falling from a tree. Whether this story is true or apocryphal, it perfectly encapsulates Newton's groundbreaking discovery, the law of universal gravitation. Newton realized that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between their centers. This force, gravity, holds the moon in orbit around Earth, the planets around the sun, and governs the structure of the cosmos itself. Newton's law of gravitation was a monumental achievement. It unified the heavens and the earth under one elegant mathematical law. It explained the tides, the orbits of comets, and the very fabric of space-time. Section 5. The language of the universe. Newton's contributions to mathematics. Newton's genius extended far beyond physics. He was a gifted mathematician who made significant contributions to the field, most notably the development of calculus. Calculus, a powerful tool for understanding change and motion, provided scientists and mathematicians with a new language to describe the universe. It allowed them to calculate instantaneous rates of change, areas under curves, and volumes of complex shapes. Newton's development of calculus was a pivotal moment in the history of mathematics. It provided a framework for understanding complex systems and paved the way for countless advancements in science and engineering. Section 6. A legacy etched in the stars, Newton's enduring impact. Isaac Newton's legacy is profound. His discoveries transformed our understanding of the universe, laying the groundwork for modern physics, astronomy, and engineering. His work continues to inspire and challenge scientists today. Newton's laws of motion are used to design cars, airplanes, and spacecraft. His law of gravitation is essential for understanding the behavior of celestial objects and launching satellites into orbit. Calculus, the mathematical language he helped create, is used in fields ranging from economics to medicine. Newton's impact extends far beyond the realm of science. His emphasis on observation, experimentation, and mathematical reasoning helped usher in the Age of Enlightenment, a period of unprecedented intellectual and scientific progress. Section 7. The Reflecting Telescope, a testament to Newton's genius. Newton's brilliance wasn't confined to theoretical pursuits. He was a polymath, excelling in various fields beyond just mathematics and physics. He was also a skilled experimentalist and inventor, constantly pushing the boundaries of scientific knowledge through hands-on experimentation. One of his most notable inventions was the reflecting telescope, a revolutionary design that addressed a major limitation of the telescopes of his time. This invention marked a significant leap in observational astronomy. Refracting telescopes, the most common type at the time, used lenses to bend and focus light. These telescopes were widely used by astronomers but had inherent flaws. However, these lenses suffered from chromatic aberration, causing images to appear blurry and distorted due to the different colors of light bending at different angles. This was a significant problem for astronomers seeking clear and precise images. Newton's reflecting telescope, instead of lenses, used a concave mirror to collect and focus light. This was a groundbreaking approach that changed the way telescopes were designed. This innovative design eliminated chromatic aberration, producing clearer and sharper images. The clarity of these images was unprecedented at the time. The reflecting telescope revolutionized astronomy, allowing astronomers to peer deeper into the cosmos than ever before. It opened up new possibilities for celestial observation and discovery, cementing Newton's legacy as a pioneer in both theoretical and experimental science. Section 8. Beyond the Laws, Newton's lesser-known explorations. While Newton is best known for his laws of motion and gravitation, his intellectual curiosity led him to explore a wide range of subjects. He conducted groundbreaking experiments with light and optics, demonstrating that white light is composed of a spectrum of colors. Newton also delved into the study of alchemy, a precursor to modern chemistry. While his alchemical pursuits may seem at odds with his scientific rigor, they highlight his insatiable thirst for knowledge and his willingness to explore unconventional ideas. Even in his later years, Newton continued to pursue his intellectual passions. He served as Master of the Royal Mint, where he applied his mathematical prowess to improve the coinage system and combat counterfeiting. Section 9. Challenging the status quo, Newton's impact on scientific thought. Newton's impact on science extended beyond his specific discoveries. He fundamentally changed the way science was conducted. Before Newton, scientific explanations were often based on philosophical arguments or religious dogma. Newton championed the importance of observation, experimentation, and mathematical reasoning. He believed that scientific theories should be based on empirical evidence and should be able to make testable predictions. This emphasis on empirical evidence and mathematical rigor helped to establish the scientific method as the foundation of modern science. Newton's approach to scientific inquiry revolutionized how we understand and interact with the natural world. Section 10. Newton's apple in the modern world. Everyday examples of his legacy. Newton's legacy is all around us, woven into the very fabric of our daily lives. Every time you drive a car, watch a rocket launch, or use a computer, you are engaging with principles that Newton helped to define. You are witnessing the enduring impact of his work, which continues to influence modern science and technology. Consider the simple act of throwing a ball in a park. Newton's laws of motion allow us to predict the trajectory of the ball, its speed, and its path through the air. We can even calculate the force with which it will hit the ground, thanks to his groundbreaking work. His law of gravitation explains why the ball falls back to Earth instead of continuing into space, a fundamental principle that governs our universe. Newton's work is also evident in countless technological marvels that we often take for granted. From the smartphones in our pockets, which rely on complex algorithms and physics, to the global positioning systems guiding our vehicles with pinpoint accuracy. His contributions to mathematics, physics, and engineering continue to shape our world in profound ways, driving innovation and discovery in every field. Section 11. A Mind Beyond Measure. Reflecting on Newton's genius. Isaac Newton was a once-in-a-generation genius whose contributions to science and mathematics are immeasurable. His relentless curiosity, his unwavering pursuit of truth, and his unparalleled intellect forever changed our understanding of the universe. As we stand on the shoulders of this giant, we are reminded of the power of human curiosity and the boundless potential of the human mind. Newton's legacy serves as a timeless inspiration, urging us to question, explore, and strive to unravel the mysteries of the cosmos. May his story ignite within us a passion for discovery, a thirst for knowledge, and an unwavering belief in the power of human ingenuity to unlock the secrets